little practice quiz. And everybody, listen, everybody's taking the quiz tomorrow. Because what is the quiz over?
Substitution or elimination?
You've been doing that since you were like 4 years old. So you... All right. What? I'll give you those in there. Right now we're doing this. Okay, right now. Everybody's paying attention, and we are doing this practice quiz. Now, make sure that you are following the directions. So what does it mean when it says I have to use substitution? Get one variable by itself. And my suggestion always is, get the one by itself that's already by itself. So that would be this y right here. So I am going to take that, I'm going to solve for that y, so I'm going to subtract the 2x. So this is what that top equation looks like when I get y by itself, right? Now I'm going to substitute what y equals in for the y in the other equation. So I have 3x minus 2 times 10 minus 2x equal to 1. Then what do I do? What do I do? Distribute. So I'll have 3x minus 20 plus 4x, watch your signs. So 7x minus 20 equals 1. Did you get x equals 3? All right, but we're not done, right? What do we have to remember to do then? We got to go back and plug it in. And our answer is going to be written as an ordered pair, x, comma, y. So x is 3. So if I plug in 3, it looks like y turns out to be 4.
It's 7. It's not.
Right? Do I have a mistake, girls?
No.
Okay. All right, that's substitution. Now, the next one looks the same. It's the same kind of problem. But it says I have to use elimination. Now, make sure you are following the directions. We're using elimination this time. So don't get x by itself. Don't do that. That would be substitution, right? What do I do instead? Multiply something by something so that when I add, things cancel. So I heard someone say, multiply the top row by -3. Would that work? Yep. I heard somebody else say, multiply the bottom row by 2. Would that work? Yep. It makes no difference. You do whatever, occurs to you. So if I go with the first one I heard, which was multiply by -3, I like to put these parentheses in here because when I multiply, I'm multiplying the whole row. Every number in the row gets multiplied. All right, so what's going to happen here? Looks like 4. See, there's your elimination, right? So looks like y turns out to be 2. And then just like before, that's my y. Now I need my x. So I'll go back somewhere. It doesn't make any difference. I'll just go here. So 3x plus 4, because I'm putting in 2 for my y, equals 7. So you guys that always work ahead of me, did you get 1?
Yeah.
For your x. Alright, that's tomorrow's quiz. It's going to be 2 problems. One of them's going to say substitution, one of them's going to say elimination. Got it? Okay. Alright, now let's get our notes out because we're picking up where we left off. So those of you who have been gone, you need to come pick up one of each of these. You've been gone. And we're going to find my notes and pick up there.
Okay, yeah, but if I don't do it now, I'm good.
Does anyone remember the last thing we did in our last class? What were we doing? Well, we were doing stuff with matrices. Does anyone remember what we were doing with the matrices? Multiplying them. And we were discovering that multiplying requires paying attention because it's a little bit confusing when we're first learning. So here we go. Ready for number 2B. B says we are going to multiply F times A. All right, so we're on number 2B, and we're multiplying F, this is matrix F, times matrix A. All right, so who remembers the rule about when we're allowed to multiply and when we're not? So we have to write down our dimensions. Trying to see if you are missing. I know Grayson. Is Gia back there? Nope. And Julia's gone. Okay. All right, so what are the dimensions here? This guy has how many rows? Two. How many columns? Two. This guy has how many rows? Two. How many columns? Two. So I have a 2 by 2 times a 2 by 2. As long as these numbers match, we can multiply. And these tell me that my answer is going to be another 2 by 2. Which means it will have 4 numbers in it, like that. And I gotta find out what those numbers are. Alright, so step 1. This number right here is in row 1, column 1. So I am gonna multiply row 1 times column 1. So negative 1, 5, negative 1, 5, and 1, 3. Remember, you write down your row numbers, and then you write the column numbers right next to it. multiply each pair and add them up. So that first number is going to be 14. Is this coming back to you? So now I move over here. What's this? This number is in row 1, column 2. So row 1, column 2. Write down your row numbers, -1, 5. And then next to it, your column numbers, 2, -4. Multiply each pair and add them up. And the answer is -22. All right, now I'm ready to move down here. Where am I? This is row 2, column 1. Row 2, column 1. So here's row 2, here's column 1. Remember what I told you last time? It's always row, then column, and we'll remember that because we're in a Roman Catholic school. RC, row, column, right? So I write down my row, 3, 0, and then I write down my column, 1, 3, and what does that add up to? We're multiplying each pair and adding them, so that is 3. And then last but not least, we have what? What is this? Row 2, column 2. So row 2, column 2 would be 3, 0, and 2, -4. So what does that add up to? What's that add up to? 6. Now, I don't still have it, but you do in your notes. Is that the same answer as we got for problem A? No. So notice in problem A, it was A times F, but in problem B, it's F times A. And in normal multiplication, like with just numbers, it's okay to go in either order, but not in matrix land. In matrix land, order matters. So it's really important, you know, that if it says FA, you got F and then A. Should be. All right, let's try the next one. D times E. Now, before we write it down, what are the dimensions of D? 2 by 2. What are the dimensions of E? 3 by 3. Can those be multiplied? No, because the inside numbers don't match. So C is a cannot do problem. We've run into those before. The rules for matrix operations are strict, so a lot of times you just can't do it. This is a I can't do it. All right, what about D? Before I write it down, what are the dimensions of D? 2 by 2. What are the dimensions of G? 2 by 3. Is that one going to be possible? Whoa, stop, stop, stop. You told me the first one was 2 by 2? And the second one was 2 by 3? Is that possible? Absolutely, that's possible. So D, here's matrix D, and here's matrix G. This one's a 2 by 2. Look, 2 rows, 2 columns. This one is a 2 rows, 3 columns. They can be multiplied, and my answer will be a 2 by 3. So 2 rows and 3 columns. So this time I have 6 numbers to find. All right? Now, would you agree that every number in this top row is going to use these 2 numbers? Think about it. This is row 1, row 1, row 1. So all 3 of these are going to be using this one. So I'm going to go ahead and do those 3 numbers first. So I'm going to be using first row, first column, first row, second column, and first row, third column. Remember, when you find the numbers inside the matrix, inside the new matrix, you're taking the row times the column. So 1, 1 times 1, negative 3, and then 1, 1 times 2, 1, and then 1, 1 times 3, 0. All right, so what's that top row look like? What do we have across the top there? This one would be what? Negative 2. This one would be 3. And the last one in the top row is also 3. So once again, first row, first column. First row, second column. First row, third column. Now, how are we going to fill these? What are we going to do to fill these? Same exact thing, except what? Second row. So you're going to be using 3, negative 2 for all of these. And then this one, and this one. So go ahead, see if you can find that bottom row. Second row, first column. Second row, second column, and second row, third column. All right, who did I say I was missing? All right, Sammy, Grayson. All right, did you come up with anything using the 3 and the negative 2? All right, so does everybody follow that we are using, for this row right here, which is second row, we're using these pink numbers right here? And then we'll go across, we'll do 1, negative 3 for this one, 2, 1 for this one, and 3, 0 for this one. I got 9, 4, and 9. What did you get? 9, 4, and 9?
Okay, so I did.
All right, it is time, which one is that? That was D? All right, it's time for you to do one now. Let's see how you and your partner can do with the last one. G-E, G times E. Before you spend a lot of time writing it all out, can we do it? Is G-E possible? What are the dimensions of G?
2 by 3.
G is 2 by 3. E is 3 by 3. You can do it. And what are you gonna end up with? A 2 by 3. So you're gonna end up with a matrix that's the same size as this one. All right, go ahead, you and your partner, figure it out while I'm erasing my board. Always remember, you're doing rows of the first matrix, columns of the second. I like to circle them so my eyes are looking at the right thing. But you have to, obviously. So to get started, did you take the first row times the first column? It's a little bigger this time, but it's the same principle. You multiply each pair and add them up. I got 0. Did you get 0 for that first spot? 1 plus 2 minus 3. Easy to make a mistake here, you have to be careful. I think I got 18 if I... We okay on the top row, my friends? Okay, so now, Macy, are you paying attention? Don't distract me. So now I'm going to do exactly the same thing. I'm going to use these numbers. Times each column. Correct me if I made a mistake. It's easy to do, especially when you're doing it all in your head real fast. Is that okay? Alright, well I thought we were done, but we're not. There's one on the back. F times G. So what are the dimensions for the F times G? So what are the dimensions of F? 2 by 2. What are the dimensions of G? 2 by 3. Doable? Yep. Do it. Do it. I'm going to have one of you come up and put your answers on the board.
like that you didn't know about mine.
Oh yeah, 2 by 3. It is 2 by 3. I was doing 3 by 2. So 2 by 3. Correct? Yeah. This one, no. After that,
Could be 2 by 2. Look at it again.
Oh, yeah, that's good.
it's like I did, but I have to look at the colors because everything's black and white now.
Alright, did you guys, did we decide that we could do this problem? And our answer was going to be a 2 by 3? Alright, who's got it? They got it figured out? Cal, you got it figured out? Let's go. Lincoln, you got it done? Huh? All right, let's just pop your answers up here, and then anybody who doesn't match, we'll just figure out who's right. I don't know what the answer is. What did you come up with? All right. What do we think? Who can check this? Do you think Lincoln is correct? Uh-oh, I saw somebody shaking a head. Are any of them right?
The first one looks right to me.
First one looks right.
Negative 16 looks
Negative
good.
16 looks good.
I think it's right.
So, okay, so we're okay with this one. Everybody's good with that one?
I think they're all right. That one, but
You think they're all right?
Yeah.
All right. What do you think is wrong, Vanessa?
I got negative 17.
For which one?
On the second one.
Here?
Well,
This one right here? All right, let's check that. So that position, Vanessa, that position is first row, second column. So we will multiply negative 1 and 5 times 2 and 1. Yeah, I think he's right. I think that is great. Are there any others we need to check? You think the rest of them are right? Luke?
But you do it like separate.
Solomon?
So
You think they're right?
that one times that.
Okay, that's matrix multiplication. Good work, thank you, Lincoln. Okay, now, let's look at part 3.
Yes, I was just making sure.
Part 3. Look at problem A. What do you notice about it? There's something different about the way that's written.
It's in a
They're just like bars instead of brackets. In fact, don't those kind of look like absolute value? And in fact, they kind of mean that, but not in the way that you think of absolute value. This is going to be a number. So when I evaluate this thing right here, these bars tell me that my answer is going to be a number, okay? It isn't going to be another matrix, it's going to be a single number. These bars represent what we call a determinant. squares have a determinant. So if you look at the notes, what are the dimensions of A? 2 by 2. What's B? 2 by 2. C, 2 by 2. D, 3 by 3. E, 3 by 3. We only find determinants of square matrices. And we talked about the other day, square means the same number of rows as columns. It's a square, like a square room, 10 by 10. Okay? Now, how do we evaluate it? Well, it's very, very simple. But again, you have to do it in the right order. Okay? I will never, ever miss one of these, because when I took Algebra 2, we did all this stuff in Algebra 2 in high school. I'll never forget it as long as I live. I failed a quiz over the determinant because I did every single problem in the wrong order. So I got an F. Devastated me. Here's the right order. Start right here. First number. 1 times 4. 1 times 4. Multiply these. It's like kind of like cross multiply. Multiply these. Then multiply these. So I have a 4 and a 6. Would you agree? Now subtract them. So it's this one minus this one. And it has to be in that order. So start right here, the beginning. 1 times 4 minus 6 times 2. So the answer is -2. Your determinant will always just equal a number. In this case, it's -2. All right, what about the next one? Here we go, we start here, and we multiply 2 times 7, and then we multiply 3 times -1, and then we always subtract. So it's this minus this. So the answer is 17. If you said 11, you weren't paying attention to your signs. This would be +3. All right, you do C. Tell me what C is. What is the answer to C? Do it exactly the same way. What do you get when you multiply the first diagonal? -3. What do you get when you multiply the other one? 8. So it's -3 minus 8. That is not 5. What is -3 minus 8? -1. Does everybody see that? -3 minus 11. Always subtract. Okay? All right, now, what about D? Well, obviously D is a little bit bigger. And we're going to do a bunch of multiplication, but it isn't going to be exactly what you're probably thinking. So here's what I want you to do. Right next to your determinant, let me get my copies down. All right, so there's my determinant. Right next to it, I want you to recopy the first 2 columns. So here's column 1, recopy it right here. Here's column 2, recopy it right here. Now we only recopy the first 2. If you do more than that, you're going to get all confused. So just recopy the first 2 columns in order. So pretend you could just cut this out, paste it here. Got it? Now, go back to your normal starting spot, just like you started here. Back to your normal starting spot, and multiply all of these together. So 1 times negative 1 times 1 is negative 1. Then multiply all of these together. 6. And finally, multiply all of these together. 0. Alright, so first diagonal, second diagonal, third diagonal. Multiply each diagonal. Now we're going to add those numbers up, and we're going to get 5. So the total of all of this was 5. Now we're going to turn around and do the same thing the other way. So now we're going to multiply these. What do we get when we multiply those? 0. 0. When you times by 0, it's going to be 0. Alright, what do we get here? Negative 6. And then what do we get here? 0. Total up, you got negative 6. So there are 3 diagonals that we start with. We multiply each one and total them up. So that's our downs, our total downs. Then we do the 3 diagonals going the other way, multiply each diagonal, add them up. Alright? I want you to think about something. Over here, we didn't have as many numbers. So we just had our downs were 14, and our ups were negative 3. And then what did we do with the downs and the ups? Subtracted. So you're going to take 5 minus negative 6. So what's the value of that determinant? 11. Alright, so it's easy, but there's a lot. So you start by multiplying each diagonal down, total them up. Then do each diagonal up, total them up, and then subtract those 2 numbers. Just like over here, it's downs minus ups. The same concept, it's just bigger. Okay, you and your partner, see if you can remember the steps and see if you can do problem E. You remembered to copy your first 2 columns. Start here. Start here.
Yeah, I didn't down.
That's the beginning. That's the start.
Yeah, I already.
That's the first number you write down.
And then adding, right? I'm doing 3 plus 4.
Get your notes. Figure it out. Figure it out. You're at top. I would love to hear some final answers. So we're going to write these right. What? 39? I have no idea. 39? Uh-oh, I see some nods. A lot of 39s? All right, let's go. First diagonal is 36. Then I got a 0. And then I got a 1. So for all of these diagonals, it should have totaled 37. Alright, then I have a negative 8, and a 0, and a 6. So that adds up to -2. And then what do I do with those two numbers? Subtract. So 37 minus -2 is indeed 39. Good job. If you didn't get 39, where did your mistake come? It's easy to make a mistake in here. Really easy. All right, one more. Do I have a volunteer who will come up and do it on the board? Volunteer. And that's the first guy, man. There you go. All right, everybody should be working along with Vanessa. It's a lot easier if you keep your numbers organized. Try not to be sloppy.
Just go away after that. Yeah, you did. Oh, okay. Did both of them are 20? Oh, both of them are 20?
All right. First of all, thank you, Vanessa. It takes courage to come up and do this on the board. Second of all, a minute ago, I said it's really easy to make a careless mistake. And we've got one up there. 3 times 4 times 1 is 12. So this is a 12. Which makes our answer then -16. Charlie? What negative? It's subtraction. It's always subtraction. Always subtraction. So you take your first to the diagonals minus your second. Always, always, always. Okay? All right, we have one more thing to learn in this section. Tomorrow, Wednesday, you will have to have your graphing calculator because Wednesday, we're going to learn how to do matrix stuff on our calculator, all right? So if you didn't bring it today, make sure you bring it Wednesday. Make sure it's charged and ready to go. We aren't using it right now. Right now, we're going to do another problem by hand. So I'm now on part 4. And matrix A is right here. And yes, I'm finding the inverse. My job right now is to find the inverse. Okay? Now, this is a 2-step process. Step 1 is find the determinant. That is what we just practiced. This one's a 2x2. These are the easy ones. You can actually do this in your head. You don't have to, but you can. Because remember, we multiply this diagonal and get 5. We multiply this diagonal and get -2. And then what do we do with those two numbers? Subtract them. So 5 minus -2 is 7. Okay, now hang on to that. Step 2 is you build a new matrix. The new matrix has a name. It's called the adjoint, but you won't need to know that. Just call it the new matrix. I'm going to build a new matrix. And the new matrix is going to be exactly the same size as the original. To build the new matrix, look up here where I'm pointing. You take these two numbers and you physically switch spots. So you're going to have 5 here and 1 here. So these two numbers switch. These two numbers stay right where they are, but if it's negative, it becomes positive, and if it's positive, it becomes negative. So these two flip-flop, and these two change signs. All right? So those are the two parts. Now I put them together, and that's my answer. So my answer is going to be 5/7, -2/7, 1/7, and 1/7. So what did I do to get my inverse? I took each of my new numbers in my new matrix and divided them by the determinant. So over 7/7/7/7. What's wrong?
I'm confused on how you got the new matrix.
I take these two numbers and I switch their spots. I take these two and change their signs. So that's negative, it becomes positive. That's positive, it becomes negative. And then I take all my new numbers and divide them by the determinant. That's your inverse. If you were to multiply these two together, the original and the inverse, everything would cancel out, and you would be left with what we call the identity matrix. It would look like that if we multiply them together. All right, let's find one more inverse. And that might be enough. Actually, maybe we'll finish this page. All right, let's find another inverse. Here we go. 2 steps to finding the inverse. What is the first thing I want to do? Find the determinant. So looking at matrix, I'm on problem 4B. Looking at that matrix, what is the determinant? What's the determinant? Help me. 4. Yep. Because it's 4 minus 0. It's 4. Now, what is my new matrix? Well, take the 1 and the 4 and switch them. and make the 3 positive, and 0 is just 0. I don't do anything with 0 because it doesn't change the sign, the next sign. Okay? So what's my answer going to be? Well, it's going to be all of those divided by 4. So what's my first number then? 1 is going to be 4 over 4. This one will be 3 over 4. This one will just be 0 over 4, and 1 over 4. And that is your inverse. All right, quickly, see if you can do the bottom one. See if you can do C. Yeah, you're right.
I was like, girl, I was like, yes. Yeah, that screams.
I don't know if I got this right or not, but I got 10 for my determinant. And then for my new matrix, I switched these 2 numbers. So I put 3 here and 2 here. And then that was positive, so I made it negative, and that was negative, so I made it positive. And then I put all of these over 10. And I noticed that the bottom row actually reduced. So I reduced it. And that's what I ended up with as my inverse. Alright, we got one more to go, we'll have to do it next time because we're out of time. Let's listen carefully for prayer. Alright, feet up. As we come to the end of the day, let's pray at full cost and speak with scripture. In the name of the Father, Son, and Holy Spirit, hail the cross, we hope, with relief, we shall not tire. Our Lady of the Hills, pray for us. In the name of the Father, Son, and Holy Spirit, amen. Class amended, go. 7-2 is due on Wednesday. 7-2 due on Wednesday.
This is 4 minutes about